Good evening, folks. Good afternoon, sorry. I want to take this time to welcome all of you, welcome all the viewers for our today's lesson, our today's class. Always on Facebook Live, we are online to bring to you the chemistry that that is going to help you in your exam and even those other students in the rest of the classes. So I want to thank you all for tuning in, for sharing my videos, for liking my videos, and also commenting. I also want to thank the students who have been watching all along. I want to thank one of my Facebook friends and a student by the name Ariana, who did the assignment and submitted the assignment, and that was very good of you. So welcome all. Feel free, let us learn and share together this afternoon. So in our last lesson, we did structure and bonding. That is on Wednesday last week. We also looked at a bit deep of it. We looked at ionic bond. We looked at the illustrations. We discussed how ionic bond is formed, and we said is a bond that is formed between basically a metal and a non-metal. So today I want us to look at covalent bond. In my introduction, I said that we have three types of bonds. We have ionic bond, we have covalent bond, we have metallic bond. In the formation of these bonds, as we said in our last lesson, we say that bonds are formed when the electrons are either lost. When the electrons are lost, when an electron is lost, another atom gains. So when an electron is lost or gained, then this we are talking of ionic bond. The other instance also is that instead of gaining and losing, in other instances, electrons are shared. So electrons can be shared. This now makes covalent bond. So covalent means sharing. It comes, the word co means sharing. So we have co and then valent. Valent, when we talk of valent, it comes from valency electrons. Valency electrons are the electrons on the outermost energy level of an element, or rather, the electrons that an element either loses or gains. So, for it to attain stability. So that constitutes valence electrons. So therefore, when these valence electrons are shared, then we have covalent. Just as we have the word co-wife, to share the husband, we have co-drivers, they share the same car, we have so many examples, co-pilot, etc. So this one is covalent, to means the valence electrons are being shared. So that is as far as sharing is concerned. We also said we have a third instance where electrons are delocalized. Some elements or atoms, some atoms delocalize their electrons in order to be stable. This we said is leads to metallic bond. So those are the three types of bonds that we have, chemical bonds that we have, from the losing, gaining, sharing, and delocalizing the electrons. So that is how these bonds are formed. So in our first lesson, in our introduction, we looked at this, and we also said that when an electrons are lost or gained, then it forms ionic bond. We looked at ionic bond and we said it is the complete transfer of electrons from one atom to another atom. We also looked at the physical the properties of ionic structured compounds. I gave you examples to do, and I think one of you did it, and by God's grace, we were able to discuss and give them the correct answer. So want to encourage all of you to be tuning in, bring more students, let them do the assignments and hand it over on my Facebook page, and I will handle it. So today, let us look at covalent bond. We see covalent bond involves sharing of electrons, by the atoms bonding. That involves sharing of electrons by the atoms bonding. The atoms can be two, the atoms can be many, can be more than two. Also, the electrons that are being shared can be two or can be many. So we shall look at that when we reach that point. Something else also we need to know about covalent bond is that the electrons shared, we need to keep in mind that the electrons shared are the electrons that are supposed to be required, that are required by the atom in order to be stable. So for example, if an atom requires two electrons to be stable, the two electrons are the ones that it requires from the other atom in order to be stable. Also, covalent bond, this basically or majorly involves non-metals. It involves non-metals to form molecules. It involves non-metals in order to form molecules. So this is what we can say about covalent bond, that it involves sharing of electrons by the atoms during bonding, and then also it also involves non-metals, and that leads to formation of molecules. Now, so that is it. A molecule is made up of atoms. So this molecule, now you remember when we were doing Gay-Lussac's law, when we did the mole, we did Gay-Lussac's law and we looked at atomicity. And we said atomicity is the number of atoms that make up a gas molecule. So the number of atoms making up the molecule is called atomicity. Now, it involves non-metals bond in order to form a molecule. This molecule, the number of atoms that make up that molecule is called atomicity. When we did Gay-Lussac's law, we defined atomicity and we said we have three types of atomicity. We have monoatomic, we have diatomic, and we have triatomic. Depending on the number of molecules number of atoms that make up that molecule. So we have monoatomic, we have diatomic, and then we have tri. So those are the atoms, the number of atoms that make up a molecule. Of course, we mentioned in our introduction that the sharing of electrons bring about duplet or octet. We mentioned last lesson that in order for an element to be stable, stable elements are said to either be a duplet or an octet. Now it is according to octet rule. We said according to octet rule, elements below 20, elements below atomic number 20, the one that we do in form 2, from hydrogen, helium, all the way to calcium, those from number 1 to number 20, these elements, the outermost energy level holds a maximum of 8 electrons. So the first energy level, we said, when we talk about duplet, we mean the outermost energy level. This is a stability of 2. An example is helium. Helium is atomic number 2. The electron configuration is 2. So the first, it has one energy level with 2 electrons. That stability is called duplet. All the other elements have an octet. Like neon, we gave an example of neon, which is 28. Sorry, neon is 28. We have 288. So for the first 20 elements, the outermost energy level, if it is beyond 2, then it has 8 electrons. That is called a stable octet. So the sharing of electrons, the covalent bonding, at the end of the day, it brings about an octet or a duplet, which is the stability that is required for an atom. So let us look at the illustrations of covalent bonding. Illustrations of covalent bond. One, we start with hydrogen molecule, and we know that hydrogen is 1. The atomic number of hydrogen is 1. So let us start with that. You remember also when we said in our last lesson, when you are doing illustrations, you use dots and crosses to represent electrons. So for one atom, you use a dot. For the other atom, you use a cross. Now this is how I always teach covalent bonding. When it is covalent bonding, that is sharing, you begin from here. When it is written H2, it is telling you you have 2 atoms of hydrogen. So what you are going to do is to draw 2. 1, 2. To show this hydrogen, this is hydrogen. This is, you have 2 atoms. You just draw 2 and let them attach like this. Now, hydrogen, the electron configuration of hydrogen, let us say now that we have 2 hydrogens, we have one here and another one here. The electron configuration of this is 1. So let me use dot for this. I use a cross for that. Now, in order for hydrogen to be stable, it requires 1 electron. It requires 1 electron in order to be stable. So in this case, you can say this one requires 1. So because it has 1 dot already, then it requires 1 cross. So this one requires 1 cross. Okay? This one has 1. So it requires 1 dot in order to be stable. So it requires 1 dot. In so doing, hydrogen will obtain the stability of helium, which is 2. So now, this is what is called a stable duplet. So in so doing, hydrogen obtains a duplet. So here, we are now saying this hydrogen requires 1 cross. That is 1, 2. So it is stable. This one requires 1 dot. So it is 1, 2. That is stable. Now come back here. These ones that they are required, these 2, you put them inside here. So I am taking this and this, I'm putting it here. X dot. The 2. Now the 2 which are remaining here, because you took a dot, it required 1 dot, you cancel this dot. Okay? This one required 1 cross, you cancel the cross. So now you don't have any other remaining electrons here. So you have hydrogen, this is X dot, it goes inside here. So that is how, so for this hydrogen to be stable, then you count this, because the electrons are shared. So these electrons determines the stability of this hydrogen and also this hydrogen at the same time. So we are saying that the protons or the nucleus of this hydrogen is attracted to these electrons. Also, the nucleus of this one is attracted to these electrons. So these electrons are called shared pair of electrons. So these 2 are called shared pair. That is a shared pair. Now, to indicate the shared pair, you find out that these are 2 electrons. That is 1 pair. So you have hydrogen here. You have hydrogen here. A covalent bond is represented by a line between the 2 to show this one represents a shared pair. I hope that is clear. Number 2. Let us look at another example. 2. Example 2, let's look at a molecule like hydrogen chloride. Hydrogen and chlorine. We know that hydrogen is atomic number 1, chlorine is atomic number 17. When you write it, you say hydrogen. So hydrogen, atomic number 1, that is 1. For chlorine, atomic number 17, this one is 287. The electron configuration is 287. You remember we said we are only interested with the outermost number of electrons. So we have hydrogen here, we have chlorine here. Okay, following this that we did here, for hydrogen, let us say we are using dot for hydrogen, we are using cross for chlorine, because we said you use dots and crosses. So this one is a dot. That's the electron configuration. So for hydrogen is 1, like that. Now for chlorine, it is 287. We are interested with the 7. So you have 7 electrons. That means you have 7 crosses. So you write 1, 2, 3, 4, 5, 6, 7. 7 crosses to represent the 7 electrons. We clear there? Hope yes. So that is it. Now, on this end, hydrogen requires 1 cross. In short, it requires 1 electron in order to be stable. To attain a stable electron configuration of a duplet, which is helium. So here, it requires 1 cross. Okay? On this other side, chlorine to be stable, you remember we are supposed to have 288. So in order for chlorine to be stable, it requires 1. So because these are crosses, then we say it requires 1 dot. So it requires a dot here. So you have taken 1 cross, you cross 1 here. You remove 1. You have taken 1 dot, you remove 1 dot. Okay? So this 2, this is what now constitutes the shared pair of electrons. Shared pair. So on this other side, now that we have 2 molecules, we have 1 hydrogen, 1 chlorine. So that is for hydrogen and this one for chlorine. Okay? Now the shared pair is this. The shared pair is here. 1 cross, 1 dot. Alright? So you take 1 cross, 1 dot here to the inside. Now you realize that we have remaining X. we have remaining, the dots are exhausted already. It was 1. Now, the remaining excess are 1, 2, 3, 4, 5, 6. Okay? So you have 6. So now, these 6 for chlorine, you distribute them along the energy level. So you have 1, 2, 3, 4, 5, 6. Alright? These 6, the 6x, the 6 crosses, because they have not been used in sharing here, then you put them along the energy level, so that you have this. Of course, in pairs, you put them in pairs. When you go to university, you learn about the spin quantum numbers, the spin quantum number, and the quantum numbers, the quantum mechanics that are used to show the number of electrons in space. Now, so in the orbitals, so for our Form 2, Form 1, Form 3, and 4, we say you put them in pairs. So you put them in pairs so that you now have 1, 2, 3, 4, 5, 6. So that is how hydrogen chloride is shown. Now, the thing you need to understand is this. The number of dots that you see here should equal the number of dots here. Okay? So we are having 1 dot, and here we are having 1 dot. The number of x should also equal the number of x here, so that you don't create your own. So you have 1, 2, 3, 4, 5, 6, 7 x. Here 1, 2, 3, 4, 5, 6, 7. So that is hydrogen chloride. For you to confirm that it is stable, you count the number of electrons there. For you to confirm stability, chlorine requires 8 electrons in the outermost energy level. Therefore, for this chlorine to be stable, then you have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 electrons, that is an octet. For hydrogen to be stable, you have 1, 2. That is a duplet. So therefore, hydrogen is stable and chlorine is stable. Another example, number 3, is oxygen molecule. You remember we said these are molecules. So next is oxygen molecule. We know that oxygen is atomic number 8. Electron configuration of oxygen is 2, 6. So you have 2 oxygen molecules here and here. You have 6 electrons in the outermost energy level. So for this one, I use dots. For this, I use crosses. So you have 6 dots here. So 1, 2, 3, 4, 5, 6. Those are 6 dots. Here you have 6 crosses also. So 1, 2, 3, 4, 5, 6. Okay, that is 6 electrons in the outermost energy level. Let's see. These are 6. For oxygen to be stable, it requires 2 electrons, so that it is 2, 8. So you take it as this requires, because these are 6 dots, it requires 2 crosses. So it requires 2 crosses. Once you have taken here 2 crosses, you cross them from the list there. So you have taken 2 here. This other one also requires 2 electrons. So we say it requires 2 dots. So it requires 2 dots here. 1, 2. You cross 2. Alright? Once that one is done, then you have 2 atoms. They are O2. So O2, you draw 2 atoms. Oxygen, oxygen. This one is a bit smaller. Let me enlarge. So you have oxygen atom. You have another oxygen atom here. Okay. So from our illustration here, we have this one. We have said will go to the shared pair of electrons. So you have x dot dot. So you have x dot x dot. Okay, x dot here. Now you have 4 dots. 1, 2, 3, 4. So you put here 1, 2, 3, 4. Anywhere along here. This also you have 4 crosses. So 1, 2, 3, 4. Okay. So you have 4 crosses. You are inside here. You have x dot, x dot. Now you realize for this oxygen to be stable, this one, for this to be stable, then you have 1, 2. You have 1, 2, 3, 4, 5, 6, 7, 8. Stability of 8 octet. This other one here, 1, 2, 3, 4, 5, 6, 7, 8 octet. So that means they are stable. Oh, I forgot one thing here. One here, what I forgot is this. You have hydrogen and then you have chlorine. So this represents a shared pair of electrons. So here you have 2 oxygens. You have 1 oxygen, another oxygen. So a line in a covalent bond, a single line represents a pair of electrons. That represents an x dot. So this pair, 1 line. This other pair, 1 line. Are we together there? You have a pair of electrons represented by 1 line, that is an x dot. The other line also for x dot. So you realize in this one it was 1. That means 1 pair. So this is 1 pair. This is 2 pairs because you have 4 electrons. Okay. Something else that we need to note also. Inside here we have said these are shared pair of electrons. These are referred to as a shared pair. That's a shared pair of electrons. These others on the outer side, these ones are referred to as lone pair. So this is lone pair, lone pair, lone pair, lone pair. Okay. Similarly here, these are the shared pair of electrons. These are shared pair. This is lone pair, lone pair, lone pair. So how many shared pairs are here? We have 2 shared pairs. This pair and this other pair. So you have 2 shared pair, 2 shared pair of electrons here. The others are lone pairs. So therefore, the number of electrons used in bonding here are 4. Okay, these are electrons used in bonding, the shared pair. The lone pairs are not used in bonding. They just complete the stability, the octet that we are saying. So that is oxygen. 4. Number 4, we look at nitrogen. 4, we look at nitrogen. We know that nitrogen is number 7. The electron configuration of nitrogen is 2, 5. Okay, so you have 2 nitrogen molecules again. So 1 molecule here, the other one here. So let me use dots for this and cross for that. So you have 5 electrons in the outermost energy level. That is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Okay, very good. Now, for this nitrogen to be stable, you remember we need 2, 8. So these are 3 electrons short of 8. So therefore, it requires 3 electrons in order to be stable. So this one requires 3 crosses. So 1, 2, 3 in order to be stable. This other one requires 3 dots. So 1, 2, 3. 3 dots like that. So once you have put here 3x, once you have put here 3x, then you take out 3x from this other side. So we are saying you have 1, 2, 3, 1, 2, 3. You cancel them out. You have 3 dots here. 1, 2, 3. Right? So now you can show that kind of bonding. So you have 1 nitrogen. You have another nitrogen here. Then this this constitutes the shared pair of electrons. So this constitutes the shared pair. So you have x dot, x dot, x dot. Okay? So you have x dot, x dot, x dot. Alright? For this shared pair of electrons, we have 2 dots remaining. We have 2 crosses remaining. So you have 2 dots here, and then you have 2 crosses. Okay? Yes. So this now is a nitrogen molecule. As we have said, this is a shared pair. This is a lone pair. This is a lone pair. So this is lone pair. This also is lone pair. So how many shared pair of electrons are here? How many shared pair of electrons are here? That is 1, 2, 3, 4, 5, 6 electrons, 3 pairs. Okay? 3 pairs. You have 6 electrons used in bonding. So that is, you have nitrogen and another nitrogen there. So one pair represented by a single line. The second pair, so x dot, another one, x dot, another one. Okay? So here you have 1, 2, 3. This one represents one pair. This one represents 2 pairs. This one represents, no, this one represents one pair, one pair, one pair. Now, if you like some, in most cases, you show the lone pair of electrons here. You can show them here. You can show these ones here. Similarly, for oxygen we had this. The other electrons that were used in bonding were dot, 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 cross, 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 cross. So you can show them like that. So this is the shared pair of electrons. These are 6 electrons, 3 shared pairs using this trick. Okay? So I hope that one is clear. Now, let us revisit what we have said. We have done hydrogen. Our example 1 was hydrogen. We said this is what we have for hydrogen. Number 2, we have done oxygen. We said this is what we have for oxygen. Okay? Number 3, we did nitrogen. That is what we have for nitrogen. You realize that here you have 1 shared pair of electrons. Here you have 2 shared pair of electrons. Here you have 3 shared pair of electrons. This one is referred to as single covalent bond. Single covalent bond. This, you can guess, is referred to as double covalent bond. Another guess, triple covalent bond. So we have 3 types of covalent bonds. We have a single covalent bond where it involves 1 electron being shared, 1 pair of electron being shared. Double covalent bond, 2 pairs of electrons being shared. Triple covalent bond, 3 pairs of electrons are shared. So that one is covalent bond. There are very many examples of covalent bonds, and you can try them out. You can try chlorine. Okay, chlorine, as we have said, is number 17. Try that at your own time. You can also try fluorine, although it's the same as this one. So if you do chlorine, then you will have done the others also. So that is a covalent bond. And lastly, maybe for further understanding, let me do that was example 4. So number 5, let me do CO2. Let me do one that has more than 2 atoms. This one is 2 atoms, 2 atoms, 2 atoms. This one you realize has 3 atoms, 2 oxygens and 1 carbon. All again, carbon is number 12 and 6. Carbon is number 6. Oxygen is number 16. Atomic number 16. Electron configuration of carbon is 2, 4. Oxygen is 2, 6. So let us look at this. Now here you realize that you have 2 oxygens and you have 1 carbon. So you have 2 oxygens, 1 carbon. So maybe you should think of, if there are 2 oxygens and 1 carbon, then 1 carbon is in the middle, another oxygen is here, another oxygen is here. That is how covalent bond does. If you have 3 molecules, it means one is here, another one is here, another one is here, and another one is in front. So in this case, we have oxygen, carbon, oxygen. All right, we have oxygen, carbon, oxygen. So let me say I am using dots for carbon and crosses for oxygen. So oxygen is 6. So you have 6 crosses. 1, 2, 3, 4, 5, 6. Carbon is 4. So 1, 2, 3, 4. Oxygen is 6 again. 1, 2, 3, 4, 5, 6. Next page. Let me turn over. So we are doing CO2. We have said we have oxygen, carbon, oxygen. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. Now carbon requires 4 electrons to be stable. Because it has 4 dots, it requires 4 crosses. Are we together? 4 crosses. If it requires 4, 1, 2, 3, 4, it is now common sense that because we have 2 oxygens, each one is going to give 2 crosses. So this carbon requires 4 crosses. That is 1, 2, 3, 4. So this one will contribute 2. This contributes 2. So 1, 2 for this, we cross. 1, 2 for this, we cross 2. Okay? Now, this oxygen requires 2 dots. So 1, 2. This one requires 2 dots also. So 1, 2. Okay? So you have 1, 2, 3, 4. So all the dots are crossed. Alright? So this contributes the shared pair of electrons. This will become lone pair, lone pair, lone pair, lone pair. So let us draw it. So you have one oxygen here, another oxygen there, and carbon in the middle. So you have carbon in the middle. You have one oxygen on this side. You have another oxygen here. All right? One carbon, oxygen, oxygen. So for this oxygen, we have that. And then this other oxygen, we have that. Okay? So for this oxygen here, we have 1, 2, 1, 2. So x dot x dot x dot x dot x. And then you have 1, 2, 3, 4. 1, 2, 3, 4. On this other side, you have x dot x dot. You have 4. So 1, 2, 3, 4. Like that. So you have this. Again, we have said this and this constitutes the shared pair of electrons. This lone pair, lone pair, lone pair, lone pair. How many shared pair of electrons can you see? How many shared pair of electrons are here? You have 1, 2, 3, 4, 5. No. Shared pair, you have 2 here, 2 here. So 2, 2, 2, 2. 1, 2, 3, 4. So you have 4 shared pairs, regardless of either side. So in total, you have 1, 2, 3, 4, 5, 6, 7, 8 electrons used in bonding. So 8 electrons are used in bonding. The others are lone pairs. They are not used in bonding. Okay. So to represent this, as we said, then we have carbon, we have oxygen, and oxygen. So the shared pair is 1, and the other one here, another one here, another one here. All right. You can show the lone pairs if you like. X, 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 dot, 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 dot. So that is how carbon dioxide looks like. Perhaps you may have learned how to write carbon dioxide, but you don't know how it looks like in bonding. So this is how we draw carbon dioxide. That is example number 5. All right. So that is it, folks. Covalent bond. Now, still on covalent bond, I want us to discuss a special type of covalent bond that is called coordinate. Coordinate or dative bond. Coordinate or dative bond. In our previous illustrations, we have seen that, for example, in hydrogen, let me use this as a rough copy, as a rough paper. We have looked at hydrogen, and we have said this hydrogen contributes 1, the other one contributes 1. We have looked at oxygen. This oxygen contributes 2. 2. This contributes 2 to make it 4. Nitrogen. This nitrogen contributes 3 electrons for sharing. This one contributes 3 electrons. We have also looked at hydrogen chloride. We have said also hydrogen contributes 1, chlorine contributes 1. We have also looked at the case of carbon dioxide. Okay, the O double bond C double bond O, that oxygen contributes 2 here, carbon contributes 2. On the other side, carbon contributes 2, oxygen contributes 2. So that is covalent. They share equally, and they contribute equal number of electrons to be shared. So let us look at a slightly different scenario that is called coordinate or dative bond. So this is defined as a special type of covalent bond where the shared pair of electrons are or is contributed by one of the combining atoms. This is a special type of covalent bond where the shared pair of electrons are or is contributed by one of the combining atoms. It can be one pair of electrons or it can be many pairs of electrons. That is why we are saying are or is, any one of them. So that is a special type of covalent bond. An example number one is NH4. Okay, this one is called, if you remember radicals, then this one is called ammonium ion. Okay, this one is called ammonium ion. So NH4 basically is where ammonia combines with hydrogen ion. Okay, where ammonia combines with hydrogen ion to form NH4 plus. Now this is possible because hydrogen, so maybe we can make some one sentence. We can say this is possible because hydrogen ion has unfilled energy level, while nitrogen has a lone pair of electrons. This type of bonding is possible because nitrogen on this side has a lone pair of electrons, we shall look at that, and hydrogen on this other hand has unfilled energy level. Maybe just to mention, we said that hydrogen, you remember in our discussion of hydrogen, we said hydrogen can either be placed in group 1 or group 7. When you go to university level, it can also be placed in group 4. It can be placed in group 1 because the characteristic of group 1 elements is that they lose an electron to be stable. So hydrogen loses one electron to be stable. That is a characteristic of group 1. On the other hand, it can also gain, as we did in a covalent bond. So this one is from an acid. This is actually a proton. Hydrogen ion. So hydrogen ion has unfilled energy level because it has one electron. Because it has lost one electron, it has unfilled energy level. So that is it. So let us look at an illustration. First of all, we begin with NH3. So we've said that is NH3 plus hydrogen ion to form ammonium radical. Actually, I'm not saying that this is a reaction, a reaction of how it looks like. I'm just using this to illustrate that ammonia combines with hydrogen to form ammonium. So in this, we begin with this part. So we know that nitrogen is atomic number 7. Hydrogen is atomic number 1. So you have 3 hydrogens. So you have hydrogen, nitrogen, hydrogen, and another hydrogen there. So let me say I'm using dot for hydrogen and crosses for nitrogen. So nitrogen is 2, 5. So 1, 2, 3, 4, 5. This is 1. This is 1. As we said, this requires 1x. This requires 1x. This requires 1x. So these are 3x already. You take out 3. This nitrogen requires 1 dot. It also requires another dot. It requires another dot. So it requires 3 electrons. From this, it requires 3. A dot from each hydrogen. So you cross 1, 1, 1 according to this. Now, because you have 3, I said if you have 3, one will be here, and then another one here, another one here, and another one there. So nitrogen will be here. There is 1 hydrogen, another hydrogen, another hydrogen. So this is it. You have one nitrogen like that. You have one hydrogen here, another hydrogen here, and another hydrogen there. Okay, this is the shared pair of electrons. So you see, you have x dot, you have x dot, and you have x dot. So x dot, x dot, x dot. On nitrogen, you have two lone pair. So on nitrogen, you have a lone pair here. Okay? You have a lone pair. So shared pair, shared pair, shared pair, lone pair. Now what happens is, when this one comes in, it does not have any electron. So what happens is it attaches here. Okay, so that you have this lone pair is donated to hydrogen so that it is used in bonding. Inakaa kama kupe. Okay, hii ni kama kupe, so nitrogen the host. So nitrogen inapeana, but this one does not give anything. It simply uses the two electrons. So you realize that nitrogen to be stable, 1, 2, 3, 4, 5, 6, 7, 8. This hydrogen is 2. Hydrogen 2. Hydrogen 2. Hydrogen 2. So this is NH3. Now, in our previous illustrations, we said this is nitrogen. So this one is a single covalent bond. This is another single covalent bond. This is another single covalent bond. Now, this one is a single covalent bond, but the two electrons are coming from nitrogen. So you indicate an arrow there to show that there are two electrons from nitrogen to oxygen. So after you have done that, because it is a positive, ammonium ion positive, then you enclose it with a square bracket and you put a positive there. Okay. So this is an illustration of ammonium radical. Let me do another radical and then we call it a day. So that was 1 for coordinate bond. 2 is H2O plus. Now this, 3. This means H2 plus hydrogen ion to form H3O plus. We know that hydrogen is always 1, oxygen is 8. So oxygen is 2, 6, that one is 1. So you have, we begin with this. So you have two hydrogens. So oxygen in the middle, one hydrogen there. So this is 1 dot for hydrogen. For oxygen, 1, 2, 3, 4, 5, 6. And then this is 1. As we have said, hydrogen requires 1x, hydrogen requires 1x, oxygen requires 2 dots. So 1x, 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 1x. Oh, sorry, I'm cancelling this. So 1x goes, 1x goes. 1 dot, 1 dot. So this is the shared pair. This is lone pair, lone pair. So you have two, you have 1 oxygen here. Sorry. First we have hydrogen, oxygen, hydrogen. 1, 2, 3, 4, 5, 6. 1, 1. We have said 1x, 1x, 2 dots. So this is 1, 2. So this and this go. X, X. So this is the shared pair of electrons. Having that, so you have 1 oxygen, you have a hydrogen, you have a hydrogen. and then this is X dot here, X dot, and then you have two pairs, two lone pairs, so one like that. Now the incoming hydrogen, we said this is H2O plus hydrogen ion. The incoming hydrogen ion uses these two electrons. So you will have that. So you have H, this is now H3O plus. If you show using what we said, then that is oxygen, one hydrogen here, one hydrogen there, one hydrogen there, but now it is using two electrons of oxygen. So 2x, they are the same. So you use that to indicate, and then you have a lone pair here. So that you enclose it like that, and you put a positive. So this one is H3O. It is called hydroxonium ion. Hydroxonium, some call it hydronium, still the same. So hydroxonium ion or hydronium ion. Now, for your assignment also, I want you to do, so assignment, try pH4. pH4, P, phosphorus. Of course, we know phosphorus is number 15. Hydrogen is number 1. So try that at your own time, alongside also chlorine. So this is initially what we said. So you try, sorry. This is pH4 positive. Please pardon my pace. pH4 plus. So that it looks as NH4 plus H3O plus. So try this, and then all shall be well. So that is our lesson for today. We have done covalent bond, coordinate bond. We have defined covalent